range of different functions. If you haven't seen the first video about functions, go ahead and go back and watch that first video. Otherwise, we are going to look at, again, domain and range of each function. I'm specifically looking at domain first, and this f function is a set of points, and our domain is all the x values for that function. So my domain in this case is going to be a list of x values. XY points, the x comes first. So I will have these 5 different numbers: -3, -1, 0, 2, and 4. Those are all of the x values. So those are the domain. Number 2, this g of x function, because I see that this is a parabola, I don't care if it's facing up or down, any of the parabolas have a domain of all real numbers. And you can either write that -infinity to infinity, or you can put the symbol all real numbers. Algebraically, that means that I can really plug in any number I want into this. For number 3, the domain of this function is going to be all real numbers except for there's this one particular number that I cannot sub in for x, and that's because I can't divide by 0. I don't want x plus 5 to equal 0. X plus 5 cannot equal 0. So if I subtract 5 on both sides, this is saying that my x cannot be a -5. So this is everything except for -5. And then number 4, it says use the graph to find the domain and range. Here's the function notation that they give us, and they also gave us the graph. Off the graph, I'm looking at x values for domain, and it looks like the furthest to the left it goes is the -3, and it actually hits that. The furthest to the right is the +3, and it actually hits that, and it hits everything in between. So for my domain, I can do this in 2 different ways. I could either write the interval from where to where. We always read left to right. So if I'm going from left to right, I would go from -3 up to 3. Because I actually hit the -3 and I hit the +3, I put a square bracket, meaning I am including that value. So this is an interval, or you could say the same thing with an inequality. I could say that all of my x's are greater than or equal to the -3. Again, it actually hit the -3, so make sure you've got that equal to bar. -3 is less than or equal to x, which is less than or equal to the +3. So it's all the x values between -3 and +3. So this is 2 different ways to say the same thing. We should become familiar with both. And the other thing they needed was range. So the range are all the y values, and it looks like I don't have any negative y values. It looks like 0 is the lowest y value. It actually hits 0. And then it goes up to a +3, which again, it actually hits the +3. So for the range, we are going to go from 0 to +3. Again, square brackets mean I actually hit the 0 and I actually hit the 3. And then I can do it as an inequality. Same way, I would say 0 is less than or equal to all of the y values. Again, I'm talking range, so y values. And those y values are all less than or equal to my highest y value, which was +3. So it's saying I'm like every y value between 0 and 3. Okay, so there's the domain and range off of our graph. And next up, it says use the context to find the domain. The context for number 5 here, it's the volume of a sphere. And if we're talking an actual real sphere, your domain has to do with usually x's or input. It looks like my r, the radius of this sphere, is kind of like my x's. That's our input. And for the domain, every number I can sub in realistically for the radius of some sphere, it should probably be a positive number. If I have a radius of 0, then I don't have a sphere. And I can't really have some negative radius on a sphere. So I need all of my radii, the r, I need them all to be greater than 0, not greater than or equal to. Even if I have a 0, that means there is no sphere. So the radius has to be greater than 0. If you do it as an interval, that would mean it's got to be everything from 0 to infinity. I'm not using a square bracket on this one. I'm using parentheses because you don't actually hit or equal the 0. It has to be everything greater than 0. And I can't really use a bracket on infinity either because I can't say, okay, go up to infinity and include that number. Like, are you guys ever going to count up to infinity? And once you get there, draw a little dot there? No, we're not going to get to infinity. So we're going to put a little parentheses there. So as for volume, our domain has to be everything greater than 0 or 0 to infinity. The next one, last one, number 6 here, again, the context is we're going to find the range, like the y values, and we're talking about a baseball. The height of a baseball thrown directly upward with a velocity of 96 feet per second is given with this equation, h of t equals negative 16 t squared plus 96t plus 7. So h of t represents the height in feet after time t in seconds. So the t is my input. That's like an x value. It has domain. The range, which it's actually asking me to find the range comes from the h of t. This is like the output or the y value. So it gives us the range. And I can look at my graph for this. They've graphed that equation. I can see an xy point, like the highest xy point that this gets to. Since I'm looking at range, I'm looking at this y value, 151. And as far as the lowest y value goes, if you look at the very bottom here, it looks like it goes below 0. But think about the context. We are talking about a baseball that's thrown up in the air. Is it ever going to go below 0? Like, is it going to go below the ground that you're standing on? No, I mean, it might bounce off the ground or whatever, but it's not going to go into any negative value. So as far as the range goes, my lowest is 0 up to the highest, which was a 151. It can actually hit 0. I'll put the bracket there. You can lay on the ground. And it goes up to the 151. There's an actual point that it actually hits, so I will include the 151. Another way to write this is with an inequality. I can say that 0 is less than or equal to all the y values, which are less than or equal to 151. So here's our range.